What if you didn't have to 3D print in layers anymore, but could make an entire object appear instantly, seemingly out of nowhere, in one solid piece? First, you take a vial of resin and set it in a machine that rotates the vial at a specific rate. Then a light turns on and shines an image at the vial. And after about 30 seconds, you take the resin and dump it out.
Okay.
Okay, so this is the finished product here. It's a little robot. Only took, how long did this take? Like 30 seconds?
30 seconds.
Yeah.
And even cooler than this is you can print things microscopically small. These are tiny structures that are almost invisible to the naked eye. They were 3D printed in the same way. No layers, but the whole volume printed all at once. Today I'm going to show you the amazing process that turns a 2D flat image of light into a 3D structure. Well, let's say that you're imaging this pi symbol here using these light rays and measuring how their intensity changes as it goes through the pi symbol. The red graph shows the data you would receive at each angle for each ray of light. So even though you're only getting one-dimensional data, this data contains information about depth based on its intensity. You know, if it's less intense, then it went through more material. So if you add all these graphs together, you get how the intensity changes at all the angles. But now here's the key. Let's say now you have some photo paper that turns white when light hits it. The more light that hits it, the whiter it turns. So now you can just reverse the process and shine rays of light that mimic the attenuation graphs you got earlier at every angle. When you do this, you end up with the original picture of the pi symbol. So by varying the intensity of light at different angles, we can create complex images. This is a special resin that hardens when it's exposed to a certain amount of light. Below a certain intensity of light, nothing happens. But once you hit a critical value, then it hardens. So these printers have a projector that shines a 2D array of light at the resin as it spins. It's literally just a projector projecting a special image onto the resin. The image it projects kind of looks like a ghostly image of the final 3D structure. The projected image rotates along with the vial. The image that it projects is created by performing tomographic reconstruction of all the 2D slices of the 3D file. And although I just explained how it's working, it still seems like magic when a final 3D structure emerges from the resin. So the file is still built on 2D slices of the 3D model, but all the slices are printed at the same time. The entire volume is formed at once. So thanks to the team at Berkeley for letting me showcase their cool technology. They're actually trying to make these printers more available to the public by making them open source. So if you want to check it out, I'll put a link to their Discord in the description.